Okay, so this is a control test that was written in June 2022. So I am going to explain what you are supposed to do in this particular question paper that you are given. Make sure that you do understand all the instructions. All right, so this was 1.5 hours, total 60 marks. All right, so make sure that you follow the instructions that you're given on that part. So we're not going to waste much time. Let us quickly rush through our instructions. We are given this question paper consists of 10 pages, okay, and 8 questions. Section A, 5 multiple choice questions. Remember what I said when we answered that June 2015 question paper? I told you guys now they are going to give you a part of multiple choice. Yes, they can give you that. They cannot give you that. Just depends, okay? Then section B and C questions must be answered in the space provided on this paper. We are given the spaces to answer. All right. Then clearly show all calculations. Calculators are allowed. Are allowed, meaning to say you can use your calculator. You can use your calculator. If necessary, round off to 2 decimal places. Okay? Take note to 2 decimal places unless stated otherwise. They can give you a certain instruction, maybe to 1 decimal place on that question. You have to follow that. But on all calculations that you're going to do, if they are not going to specify, you use 2 decimal places. Please be careful, okay? Then diagrams are not necessarily drawn to scale. All right, meaning to say, do not measure diagrams. They are not to scale. Okay, it is in your best interest to write neatly and legibly, meaning to say everything must be clear so that the marker is going to mark your work properly. You know, he sees everything or she sees everything properly. So just be on the right track to do so. So I'm not going to waste much time. I'm going to quickly rush and answer these questions so that we understand how we're supposed to have answered these typical questions. Let's go through this. Section A, multiple choice questions. Question 1. Choose the correct answer, circle the letter, all right? So you choose the correct answer, then you circle the letter of the correct answer, all right? On the answer sheet provided on page 4. So on page 4, they provided something like this, all right? This one here, it was 1.1 here. This is A, B, C, and D. So you're going to circle that. We're going to talk about that. But for now, let us just find our answers. Then we'll circle these answers later on. All right. So that was your instruction. All right. If you want, okay, there's this part here that I wanted you to see. Here they're saying, if you want to change your choice, put a cross through the wrong letter and circle your new choice. So maybe you made a mistake, you just put a cross, then you circle the one that you want, which is the correct one, okay? Let's start. 1.1, the lowest common multiple and the highest common factor of 27 and 36 are. So there are 2 things that we need, the lowest common multiple and the highest common factor. So it's either you're going to test these numbers to say what is the lowest common multiple, or just calculate, because you know how to calculate this. All right, how do I calculate the lowest common multiple and the highest common factor? First of all, we know that we must express these 2 numbers as product of their prime factors. So 27 as a product of its prime factor, and you do the same thing on 36 as a product of its prime factor. That's the quicker way that you can do it. All right, 3 is a prime number of 27, so you can divide 27 divided by 3, you are going to get a 9. Remember, as they said, you can use your calculator. You divide again by 3. 9 divided by 3, that's a 3. You divide again by 3. 3 divided by 3, that's a 1. You are done. You do the same thing on this number. The smallest number that you can use is a 2, all right? Check note, there's a 6 here. So 2, 4, 6. So meaning to say we can use what? We can use a 2 first. Divide by 2. 36 divided by 2, that is going to give you 18. You divide again by 2, that's a 9. All right, so as you can see, we can't use a 2 this time. It is not a factor of 9, so use what? 3. 9 divided by 3, that's 3. 3 into 3, that's a 1. So these are your factors. So remember that you can write these numbers as 27 is equal to 3 times 3 times 3. That's if you want, or you can just write as 3 to the exponent of 3. The same thing, 36, you can write your 36, 2 times 2 times 3 times 3 like this. 2 times 2 times 3 times 3. So let's start with the first one, the lowest common multiple, which is the LCM. Remember the LCM, you take where the numbers are many or where these numbers are plenty. First of all, the number is supposed to be there. As long as the number is present, you have to take it. Like the 2, we have a 2 here. So we're going to take this 2. There is a 2 and a 2 there. So it is going to be 2 times 2. Okay, we do not have a 2 this side, so you take these ones, which are only available there. There are 3s here. There are also 3s here. But where do we have these ones? Where are they? Where we consider to say they are many. They are plenty. They are many. Where this is the one. 1, 2, 3. 1, 2. So these ones, they are just 2. These ones, they are 3. So you take where there are many. All these ones. 3 times 3 times 3. Your calculator is allowed. So on your calculator, I want you to multiply this properly. You're going to obtain 108. That is 108. So this is your LCM. You do the same thing. You know these calculations. So do not, guys, do not. This is just, okay, straightforward. The HCF, all right, the highest common factor, remember, it must be common. A factor must be common on both numbers. So 2 is not common, meaning to say we cannot take this part of 2. We move on to 3. We have got a 3 here. We've got a 3 here. So it's going to be 3. There's a 3 here. There's a 3 here. So it's going to be 3 times 3. And what is 3 times 3? That's a 9. So meaning to say, what is the proper answer? Because we need where the LCM first is 108. The HCF is 9. So this is the proper one, 108 and a 9. Remember, they said lowest common multiple and. So we must start with the lowest common multiple followed with the what? Highest common factor. So our answer was going to be at C. So we are going to circle our answer at C at the end as the instruction that you are given that you must circle your answer. So this is what we're going to do. 1.1, you just circle your answer at what? At C. Just like that. So I just hope this is not like, guys, you just need to understand. So if you know this, like if you can just check, okay, these are the numbers, you check, okay, which one can be LCM, you divide, you say, okay, this is the one. 108, you divide by 27, you also divide by 36. You see that. That is that is the LCM. So you can even test this one. If you divide 27 divided by, it's not proper. So you can even test these values 1 instead of working. But if you know your workings, you can just do your workings, which is fine. All right, let's check 1.2. They are saying a factory makes 5,000 cell phones per week, each week. How many cell phones would they make if they increased production by 50%? They increase the production by 50%. So how do I calculate an increase? it follows that to calculate an increase, it is simply the percentage increase, all right? The percentage increase over 100 times the amount that you're given. So in this case, we are not given like the amount, like the cost. We are given as the number of cell phones. So you're going to multiply to the number of cell phones. That's an increase. We need to know how it increased by what. If you know this 50%, guys, it's a half. It's a half of the production. So you can just half of this, you're done. Or you can just use this concept, percentage increase over 100 times the number of cell phones. What is our percentage increase? It increased by 50%. So it's 50 over 100 times the number of cell phones. How many cell phones do we have? 5,000. So this is our increase. We are saying it increased by, that is what we are talking about there. This is it increased by. It increased by what? So that's 50 over 100. Remember, they said calculators are allowed. So times 500, times 5,000. That is 2,500. So meaning to say the increase is 2,500 rand. This is the increase. It increased by, but that is not our question. The question is, how many cell phones would they make if they increased? So this is the increase. So how many are they going to make? How many are they going to make? So now we are going to add. Originally, they were producing how many? They were making 5,000. Guys, why am I putting the amount here? Sorry for that. They were producing 5,000 cell phones originally. In the first place, before they increased anything, they were producing 5,000. Okay, this is what they were making in a week. Now they increased by 2,000. To increase is to add. If they reduce, you subtract that. So to increase, you add. Now they increased by 2,500. So at the end, what are they going to make in a week? So we add 5,000 to what we got, which is 7,500. So now they are going to produce 7,500 cell phones a week, or they are going to make 7,500 cell phones a week, which is on D. So our best answer there was going to be a D. So the increase, you first calculate your increase, and after calculating your increase, you add, because they said how many are they going to make, like the production. How many cell phones are they going to make? So you don't just calculate your increase and leave it there. No, you must also add when it is like this. 1.3, calculate minus 18 plus 6 minus 10. So this is just your calculator. You can just take this on your calculator, guys. This is just 1 mark. And remember, just an answer there. So just use the calculator properly. Minus 18. This is the minus here that you press, minus 18 plus a 6. Then we subtract 10. So this time we subtract 10 like this. Okay, that's minus 22. And where are we having? Minus 22 is on C. So we are going to circle our minus 22, which is at C on this part that we are given on our table here. 1.3 is C. Just like that. Okay, let's check another question. We move on to 1.3. All right. 1.3, they must, okay, so this was from that 1.3 is the one that we just answered, I mean. So we need 1.4 now. 1.3 is the one that we just answered. So 1.4 is the rule for the input and output values that are represented in the flow diagram below is, what is the rule? This one. So we are given answers here. So remember your rule, you are supposed to refer it in terms of the output, in terms of the output. So if we refer this in terms of the output, it means I'm not going to think about this C and D because they're giving us as input is equal to. So we are not going to think about this. So we have to think about these two. Output is equal to. Okay? So let's check number one. Output is equal to input minus 6. So let's check what we have. If we take the output, all right? If we take the output in this case, they are saying input minus 6. The input, this is your input here, the ones that you have in the beginning. Then the end values are your output values. So this is what you do. You just remove this to say, how do I get minus 3? Because minus 3 is on the output. So if I take this statement, let me take this. Input, the input corresponding there is what? Minus 9. So you're going to have minus 9 like this. Minus 6. Minus 9, minus 6. What are you going to have? Minus 15, which is not minus 3. So this is totally wrong. Do it on the same way again, on the same number, on another number. Minus 7 is the input. So input minus 7 minus 6. What are we going to have at the end? This is minus 13, not minus 1. So this is wrong. This is totally wrong. So meaning to say this one is wrong. So we are just left with B. So let's prove to see if B is the correct one. On B, its output is equal to input plus 6. All right. Output is equal to input plus 6. Okay, let's take one on the input. The input is minus 6, is minus 9, sorry. So let's take minus 9 plus 6. They are saying input, then you add 6. So let's add 6. Let's add 6 on that one. If we add minus 9 plus 6, that is going to give us minus 3, meaning to say this is true. Minus 9 plus 6. This is minus 3. Exactly what you have there on the output. We are getting a minus 3. Exactly what we have here. But let's prove again with another one. Let's take the input. You can take anything, any part. Let's take this one, last one, 5. The input is 5. They are saying everything on the input, if we add a 6, we must get the output. Okay, 5 plus 6 is equal to what? 11. And it is exactly the 11 that we have there. So this rule is correct. This is the rule that exactly satisfies what we want. The output is equal to input plus 6. So the answer was going to be on a B. So that is the one that we're going to have. So the answer, we're going to circle a B, 1.4. That's a B. So you just circle that part. Remember, this is the instruction that you are given. All right. So, okay, where is that part here? 1.4B. All right. So that was our question. Let's move on to 1.5. 1.5, the following is a verbal. The following verbal expression is given. So it's just a verbal, like you are saying something, but they want you to write it. So the correct algebraic expression is, they are saying subtract a number from the product of 3. All right. From the product of 3 and that same number. So it's the product of 3 and the product of 3 and that same number. So let's say the number, as we can see, the number that we do not know is given as y in this case. So you check how they wrote it on your answers. They wrote in terms of what? In terms of y. So meaning to say the number that we do not know is y. So we are going to subtract y from where? From the product of 3 and that same number. So the product, it means 3y. But what are we going to do on 3y? We are going to subtract a certain number that we do not know, and that number is what? Is y. So the best answer was on B. Okay, so this, it means the product of 3 and y, then we subtract y, which is exactly this statement that we are given on that part. So our answer was going to be a D. So please be careful on that part, all right? How you answer these questions. So that was your section A, which was question number 1, the first part of your question number 1. Then section B, we move on to the numbers, operations, and relationships. All right. Question 2, it was on whole numbers. State whether each of the following statements is true or false. These statements. Okay. 0 divided by 86 is equal to 86 divided by 0. No, this is wrong. It's like 2 divided by 4 is equal to 4 divided by 2. No, this is totally wrong. But if you do not understand, just take your calculator to prove that. You see that, okay, this is it on your calculator. So I want you to say that this is totally wrong. The first one is 0 divided by 86. 0 divided to 86. That's a 0. Okay, so the first one, we get a 0 there. Let's move on to the other one. 86 divided by 0. This does not exist in math. You cannot have a denominator. You can't divide by a 0. That's why it is giving you math error. This does not exist. It is not there in maths. You can't do that in mathematics. You can't divide by a 0. That is what it means. So this does not exist. So meaning to say this is false. These two are not equal. Okay, what about these two? If you do not understand this, just take your calculator, add. The first one is 10. Okay, let's take the first one, sorry. The first one is 10 plus, open a bracket. The way that it is there, you open a bracket, you add 5 plus a 12 like this. Close that bracket. What is the answer? 27. So you get a 27 here. Is it equal to this part on the right-hand side? Let's do it and see. On the right-hand side, how is it given? Open bracket. So you open a bracket. 10 plus 5, that's 10 plus a 5. Close the bracket. Plus a 12. What are you going to have? A 27 again. So 27 is equal to 27. So is it true? Yes, this is true. The left-hand side is equal to the right-hand side. So it means these two statements, no matter they are written in different ways, but they are the same. They give us same answers. So it is true. Okay. Simplify the following, show all calculations. All right. So on this one, remember your board mass concept. Your board mass. Brackets off. There are brackets here. So you must first simplify the brackets. So let's simplify the brackets. 15 plus 20. If you add 15 plus 20 on your calculator, that is 35. Divided to, there is a 7 minus 2. So we have removed the brackets. We added what is inside of the brackets. Then we move on. Is there a division? Yes, there is a division. These two numbers here, they are dividing. So it's 35 divided to 7. So this is what we just do, guys. Just use your calculator. If you've forgotten your multiples, just divide 35 divided by 7. What are you going to have? That's a 5. So meaning to say, from dividing these two numbers, we are going to obtain a 5 minus a 2. 5 minus 2 is what? Is a 3. So on this one, you are going to have a 3 at the end. Okay, so make sure you present your work properly. So that was what you had on this part. Let us check another question, a continuation 2.3. So on 2.3, we are given We are given Tavo, Silas, and Jacob. There are three guys who are there. These three guys, they are paid a total of 1,500 rand a week. All right, 1,500 for the work that they did. For the work they did. So they worked and they were paid 1,500. They decide to share the amount in the ratio respectively. Take note, when they say respectively, it's in this order: Tavo, Silas, and Jacob. So in the order that you are given, it's this way: Tavo as to Silas as to Jacob, according to this way. Respectively, Tavo followed by Silas, followed by Jacob. Their ratio is given like this, which is 6 as to 5 as to 4, the one that you're given. So Tavo is 6, Silas is 5, Jacob is 4. That is what it means. So that is your ratio. So the question is, how much of money will Silas receive? How much will this guy Silas receive? So according to his, or to the ratio of Silas, his ratio is 5. The ratio of this guy is 5. The ratio, it corresponds to 5. Take note, Tavo is 6, Silas is 5, Jacob is 4. You take the way corresponding respectively. So this is the ratio for Silas. So it means the money that Silas is going to receive at the end is his ratio 5. Okay. His ratio of 5 over the total ratio. So what is the total ratio? The total ratio, you add total ratio, you add 6 plus 5 plus 4. So this was going to give you a 15. So you divide to the total ratio. It's his share over total ratio. Over total ratio. Then you multiply to the amount that they are sharing. They are sharing what? 1,500. His amount over the total ratio times the total amount. You have the amount for anyone that you want. So if it is Jacob, you take the ratio for Jacob, which is 4 over 1, the total ratio times the amount. The ratio, the amount that Tavo received, the money, the ratio for Tavo, which is 6, over the total times the money they shared. Just like that. Just like that. So this is what you're supposed to do. So from there, you just divide 5 over 15 like this. What are you going to do? You multiply 1,500. That is going to give us 500. So the answer was going to be 500. So meaning to say, at the end, Silas was going to receive 500 rand as the share. That is the share that he was going to receive. All right. Integers on question number 3. We are on now on integers. State whether each of the following statements is true or false. So is it true? So on the when you are given numbers like this, just use your calculator to test. Okay, don't worry, it's just 1 mark there. Just use your calculator. You test this way, the same way that we did that other question. So there is -5, this one -5. Open a bracket. 2 plus 1, 2 plus 1. What are you going to get? -15. So on the left hand side, we are going to get -15. Is it equal to this? You calculate that to see if it is equal. You have to calculate that. Open a bracket, -5 plus a 2. Close the bracket. Plus, okay, open a bracket. -5 times, okay, sorry, there's a times there. The times you're multiplying. There's a times like this, okay? So let's move on. minus 5 times a 1. You close the bracket. What is it that you're going to have? Minus 15 again. These two, they are equal. So this is true. Very, very true. Okay. Let's move on to another one. X times minus 1 is equal to minus 1 times x, all right? X times minus 1, it's minus 1x, which is equal to minus 1 times x is minus 1x. So these two are the same. Remember, minus 1x is same as minus x. So minus x is equal to minus x. This is also true. Okay? Simplify the following. Show all calculations. We are back again to the bodmas concept. The bodmas. Brackets off. They are brackets. Yes. What is inside of the bracket? Simplify. Minus 15, minus 14 plus 5. So you add minus 14 plus a 5. So if you add minus 14 plus a 5, that is minus 9. Then there's a times there, minus 8. You are done with the addition. You inside of the bracket. That is why you have to remove that brackets off first. Then you multiply. Minus 9 times minus 8 minus, that's a positive. 9 times 8, that's 72. But you've forgotten this. That's a minus, and a minus gives you a positive. Remember, they said calculators are allowed. So make sure you use your calculator to verify your answer. Minus 9 times minus 8. What is it that you're going to have? Positive 72. So that is what you're going to have at the end. Okay. So be careful how you answer your questions. So that was our 3.2. All right, 3.3. There's something there. They are saying 3.3. All right, 3.3. Oh, I left something here. 3.3. The sum of two numbers is minus 2. Their product is minus 24. Okay, what are the two numbers? So the sum of two numbers. So they think of the product first. The product of two numbers is 24. The product. So you think of the factors of 24. Yes, there's a minus there. So just think of factors of 24 first. Product, because product, these are factors. All right. Factors. That's a product. So think of two numbers because there are two numbers. So think of two numbers that you multiply and they give you 24. What are the two numbers? So if you do not know, just do like this. 24, express it as a product of its prime factors. 2 into 24, that is 12. 2 into 12, that is 6. 2 into 6, that is 3. 3 into 3, that is 1. So 24 is a product of 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. But since they said two numbers, so if I take these two, it means I'm going to have 2 and the rest of these numbers. 2 times 2, 4 times 2, 12. So I have 2 and 12. But take note, they said the product is minus 24. So if I multiply 2 and 12, I cannot get a negative 24. I'm going to get a positive 24. So to get a negative 24, one of these numbers must be a negative. One of these must be a negative. So meaning to say it can be 2 and minus 12. But as you can see, if you add, because they are saying the sum, it means when you add, you must get a minus 2. If you add these, you are not going to get a minus 2. Minus 2 plus 12, that's a 10. This is wrong. 2 plus minus 12, that's minus 10. This is wrong. So these are not going to work. You move on to another one. You can take, remember, you took 2 in the first place. So take these ones this time, 2 and 2. You combine these because we need two numbers. So you must have two numbers. 2 times 2 is what? 4. Then we have got 2 and 3. 2 times 3 is what? It's 6. So 4 times 6, you get 24. But as we need minus 24. So to get minus, one of these two numbers must be negative. So I can have minus 4 or I can have 4 and minus 6. Okay, these two numbers, if I multiply these two numbers, I'm going to get minus 24. That is the product. But they are saying the sum must be minus 2. The sum, if we add, let's add. Minus 4 plus 6, you are going to get a positive 2. This is wrong. 4 plus minus 6, it means 4 minus 6. This is going to give us minus 2. This is correct. Remember, they say the sum, if you add the two numbers later on, you must get a minus 2. But first, the product or the numbers, if you multiply them, 4 times minus 6 is what? Minus 24. If you add, you must get a minus 2. So it's 4 and minus 6. So this type of equation, it's called trial and error. You try factors. Don't just try two factors or two products. Then if they fail, you leave that question, then you say it's wrong. No, you try again. You move on to another one, you try until you get the exact one. But as you revise, that's why I say, guys, please revise more questions. As you revise more questions, you will see these numbers, they will just be visible to you. They'll be just visible. The moment you just read this statement, you even see the numbers. Okay, the number there is going to be this and this. You will not even try as many numbers like this. But if you do not know this, then you have to try like what I'm doing. So the two numbers is 4 and minus 6. So that's 4 and minus 6. These are the two numbers that we needed, that if you multiply, you get minus 24. If you add, you are going to get a minus 2. So that was what you're supposed to have calculated. Very, very sorry for that here. You're supposed to have calculated here. Very sorry for that, for this dragging. Question 4, which is on common and decimal fractions. Common fractions and decimal fractions. Okay, let's see the first one. Simplify the following. Show all calculations. Okay, so this is addition and subtraction of common fractions. So this is 9 over 15 plus 2 over 3. This is minus 2 and 5 over 5. Minus, this is 2 and 5 over 5, like this. 2 and 5 over a 5. So how do you simplify this? You write it as an improper fraction. You multiply this, you add the numerator. So 5 times 2. What is 5 times 2? That is 10. 5 times 2, 10 plus 5, which is 15. So you multiply, then you add. But guys, if you do not know this, just use your calculator, right? If you've forgotten this, 2 times 5 first, that is 10. Then after that, you add a 5 on the numerator. That's a 15. So it's going to be 15 over a 5. So this is going to be 15 over a 5. All right. So that's minus 15 over a 5. You multiply, you add. All right. We are supposed to add, then subtract. But in order for us to do this, we must have the same denominator so that it can be easier for us to add. So you ask yourself, what is the LCD of these denominators? What is the lowest common denominator? Which is the lowest common multiple of 15, 3, and 15? You see that it's 15. 3 times 5 is 15. So 15 is inside of this 15 again. So already here, there is a 15. So there's nothing that I'm going to do. We're just going to remain like that. Remember, we said our LCD is 15, or our LCM is 15. So already this one is 15. You leave it like that. So you must have a 15 also here on these 3. You must have a 15 because you must maintain that. So how can we have a 15 here? What are we going to do? We are going to multiply by what in order for us to get a 15? So if you do not know this, just divide, okay? This number, the LCD, 15, divide by this number so that you know the number to use when you are multiplying. 15 divided by 3 is what? It's 5. So it means 3 times 5 is equal to what? Is equal to 15. So the number that I need to get this 15 is a 5. So I multiply by 5, both the denominator and also the numerator by 5. So if I multiply by 5, what does it mean? It means we are going to have 2 times 5. What is 2 times 5? That is 10 over 3 times 5. We now have our 15. Okay? Minus, you do the same thing. You need to maintain the LCD throughout. So our LCD is 15, but here there is a 5. So the question is, how can we get a 15 here? How can we get a 15? Because we need a 15 throughout so that we can simply combine our fractions. So to get a 15, given the LCD of 15, I just divide by this number that I'm given, which is in the denominator. 15 divided by 5 is equal to 3. So it means 5 times 3 is equal to what? 15. But if I know that I'm going to use it, I do not need to do this. No, yeah, I'm just showing you guys like exactly what you're supposed to do. But if you know that, okay, 3 times 5 is 50, there is no need for you to do this, okay? If you know that 5 times 3 is 15, there is no need for even you doing this. But this number, you have to also use it in the numerator. So now you can multiply 15 times 3. You are going to obtain 45 over 5 times 3. That's 15. So why are we doing this? Why? It is because that if the denominators are the same, like what we are seeing here, they are the same, you can combine, you can add or subtract your numerators under the same denominator. So we can start by adding, because they are the same. 9 plus 10. What is 9 plus 10? That's 19 over 15, because the denominator is the same. All right. Minus 45 over 15. We subtract 19 minus 45. Okay, so that is going to be minus 26. On your calculator, just do that. Subtract, say 19 minus 45, like this. This is minus 26. So we are going to have minus 26. Everything over what? Over 15, just like that. Yes, you can rewrite the way that you want. Minus 26 divided by 15 like this. It is the same thing as shift. You press this, okay? Shift, then you press this SD like this. It's minus 1 and 11 over 15. So you can even write it as minus 1 and 11 over 15 if you want, or just leave it at this stage. It's fine. All right, that is how you're supposed to answer this. So you express first your fractions as improper fractions for you to add or subtract. After that, what do? You now consider the denominators to be the same. You have to look for the LCD first. By knowing the LCD, then you will know what to do on each denominator for it to look like the LCD, for it to be like the LCD. Okay, this is a 2-mark question that we are given on 4.12. To simplify again this one, so there you just add the 2. This is 7, comma 8, 6. So if you were to add, all right, if you were to add this plus 3, 7, then you have to subtract 4, 9, 9, 9. So remember your grade 7 concept, you were using those decimals, 7, 8, 6 plus 3, 7. You put a 0, then you add the number 6 in common. You add here. That is going to be 15, comma, you put a 1, that is going to be a 10, 11. Then after that, you subtract. Yes, you could have done that. But here they said, guys, we can just use our calculator straight. So you can add first these two numbers straightforward on your calculator. This is going to be 7,86. You're going to have the same answer just like the one that I just showed you there, which is going to be 10,56. Then you subtract 10,56 minus 4,999. So it's either you're going to do that 11,56 minus 4,999, put a 0 there, then you subtract. But as you can see, just for the 2 marks there, they just need you to subtract direct on your calculator minus 4,99. They also want to know, are you able to use your calculator? 6,561. So this is 6,561 like this. But remember the instruction. Whenever you are given decimals, they say to 2 decimal places. So you can round off to 2 decimal places. It will be 6,56. Because we are given the instruction. Remember that instruction from your question paper on the first part. Unless stated otherwise, unless they give us a certain instruction, that is how you can have it. All right, 4.2, we are given a guy who is Elvis. Elvis spends 21/100 of his pocket money on chewing gum. Okay, 0,546 of his pocket money on a pair of shoes, then 28% of his pocket money on a present for his mom. If Elvis gets 300 Rand for pocket money, what percentage of his pocket money does he have left? The one that is left. What percent? The question is not just the pocket money, but what percentage? There's a lot there. You need to have to know the money that he is left with. Then you can calculate the percentage that he is having now. Okay, so let's start by what he spent. He spends a lot from this money. What did he spend? The first place, 21/100 of his pocket. Of means times. So you used 21/200. Sorry, 21/200 of, that is times his pocket money. What is his pocket money? 300 Rand. So this is the first one that you used for the chewing gum. All right, just to buy a chewing gum, it used 21/200 of the money, meaning to say it's 21/200 of that money times the money that he had. That is what it means. Of, that is times. So he used 31,5 Rand. So you used 31,5. But this is money. You put another zero, another decimal place, which is a 0, to make 2 decimal places. So this is the first one that you used to buy the chewing gum. All right, that's for the chewing gum. Then we move on to the pair of shoes. He used 0,546. They gave us as a decimal. Remember, a decimal is also a fraction, just like what we had. 21 over, just look, guys, 21/200 like this. What is it that we were talking about? It's a decimal. 0,0. They could have said here, he used 0,105 of, just like here. They gave us as a it's the same thing they can give you just to confuse you. It's a fraction, it's a decimal, it's a percentage, one and the same thing. You just multiply this decimal as it is. Don't even change it to a fraction as it is. So it is going to be 0,546 times the amount his pocket money is 300. 0,546 times his pocket money, which is 300, meaning to say he used 163,68,8, sorry, 163,80. This is to buy a pair of shoes. Then 28% of his pocket money was used on a present for his mom. So that's 28%. 28% means 28 over 100. That's 28%. So 28% of 300 is going to give us 84. So he used the 84 rand to buy a present for his mom. But the question is, this is what he used. He used this, he used this, he used this. So what is the total that he used in all? We have to add everything that he spent. He spent how much? So we need the total spent, the total amount he spent. All right, so let's add 31,5 plus 163,8 plus 84. So meaning to say Elvis spent 279,3 rand. 279,3 rand, 30 like this. This is the total he spent. But the question is not about the total he spent. No. What percentage of his pocket money that is left? So what is left now from what he had? So Elvis is left with what? So he is left with what? He had 300 rand in the first place. He spent 279,30. So what is left, you subtract to know what he is now left with. So you are going to get 20,7, which is simply 20,70. This is the money he is left with, not the percent. The question is, what percentage of his pocket money? So remember, after calculating what he is left with, this one, to calculate the percentage. So how do I calculate the percentage? So the percentage left is going to be equal to the money that is left. He is left with what? 20,70 over all what he had before. He had 300 in the first place. So what is left over what he had before in the original place times what? 100 over 1. Remember, always to find a percentage, you multiply by 100 over 1. That is 100%. So that is it. So that is what we're going to do. 20,7 over, we divide by 300. Then whatever that you're going to get, you multiply to 100%. So that was going to be 6,9. So meaning to say Elvis is left with the 6,9. All right, to 2 decimal place, that is 6,90 as the instruction of our question paper, to 2 decimal place, or you can just leave it as 6,9. So meaning to say the percentage left on what he used, what he used is going to be 6,90. He spent all this. This is what he spent. Remember this. So the total spent, which is this one, that is the one that we calculated. Then from the total amount spent, find the amount he is left with. All right, amount left. So the amount left is what he had minus what you, it's like you spent something. How do you calculate the amount that you are left with? Is the money that you had before minus the money that you have used. You have used 279,3, so you remove that. You have used it, it's no longer there. So you are just left with 20,7. Then that now you express as a percentage. What percentage? That is the instruction. 3 marks for that. So I think that was it. So this is the whole part that you're going to have here. Okay, so exponents. So on 5, there we are given match column A to column B. You match to match, that is to say, this here in column A, is it this one or it is equal to this one? So they are giving us the first one, 6 to the exponent of 2. Can we say 6 to the exponent of 2 is this? No. 6 to the exponent of 2 is 36. 2 times 3, that is 6. 2 times 3, that is 6. 6 times 6, that is 36. So meaning to say, the 6 to the exponent of 6 is best matched to the column be this one on the other one. So that was going to be 2 times 3 and the bracket times 2 times 3 in another bracket, all right? Then 2 to the exponent of 6 means 2 times 6 times. This is exactly what we have here. 2 to the exponent of 2 times 2 to the exponent of 2 times 2 to the exponent of 2. 2 plus 2 plus 2, that will be a 6. So this is the best match that we are given. So you are supposed to match to the one that corresponds exactly to what you are given there. So the best match for this one was this, okay? I think that was a pretty clear question. Simplify the following, show all your calculations, all right? The cube root of 127 minus 2 times this. Okay, so we are given the cube root, so that is the cube root of 127 minus 2. Let's subtract. 127 minus 2, this is 125, times minus 5 to the exponent of 2. It means minus 5 times minus 5, that is positive 5. What is the cube root of 125? The number that multiplies itself 3 times to give us 125. The cube root of 125 is simply a 5 times 25. If you do not know this, a calculator is there. That is your only friend in exam that you can actually do, trust, and use. That is the cube root. The cube root is shift. You go to this under the square root here. So shift like this. That is the cube root of 125. And that is going to give us a 5. So after that, you multiply 5 times 25. So times 25, what are you going to have? This is 125. So if you multiply 5 times 25, you are going to obtain 125. Just like that. All right. Question 5.3. We are given, Jolene remembers a teacher saying, when you divide powers, you subtract exponents. Okay, then we are given that Jolene simplified this as follows: m to the exponent of 4 over this. You simplify. Okay, this is totally wrong, guys. You cannot, remember, these are not the same, so we cannot subtract. This is totally wrong, the way that Jolene simplified. Anyways, let's see what the statement is all about, but that is totally wrong. What, okay. It seems like I left something. 5.31. Where is the question now? Seems like the question, I left out the question. All right, the question is nothing. Jolene remembers the teacher saying, when you divide powers, you subtract exponents. Jolene as follows. So where is the question now? All right, I need the question here. Okay, sorry for that, guys. I need the question. So there we're just given 5.31. We are not given the question. So I do not know. What was the question here? Okay. Anyways, 5.32, provide the correct answer for this. So this cannot be simplified. Remember, the bases there are not the same. So this cannot be simplified. This cannot be simplified. So in actual sense, that statement, we do not know what was going to be the question there, but whatever that this guy Jolene was doing is wrong, because one, you cannot just subtract because you are dividing. It is because you are dividing, okay, exponents. That's when you subtract the powers. Not to say when you divide the powers, You can't divide the powers, all right? So the question is not there, but here we can just correct this the way that she remembers, because the teacher cannot say this. The teacher can say, if the exponents, all right, if you are dividing exponents, if dividing exponents, you can take it that way, okay, of the same base, okay, subtract powers. So this is what the teacher was supposed to have said. So they, like we saw that, I think maybe I just left out when I was putting this on the on this software for us to revise. So that is where I left out the other part. So this one, like I said, when they say provide the correct answer, this cannot be simplified, so you just rewrite as it is. So this cannot be simplified. You just rewrite your answer as it is. That is m to the exponent of 4. Everything over n to the exponent of 6 cannot be simplified. Why? The bases are not the same. The bases are not the same. All right, then we are given another part, which is number patterns, the patterns, functions, and algebra. The pattern below is made up of squares. So these are squares which make up the pattern. Study the pattern, then answer. The first thing is study, then answer. So if you answer without studying, you're going to be a problem. Study this. What is it that you are seeing? According to this, we can see that the first pattern, there is a one box there, just a square, just one square. So there's just one square. The second one, the second pattern, 1, 2, 3, 4, 5. There are 5 squares. The third one, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 squares. This is what we can see. And according to this, we can even conclude to say what is exactly that is happening from the first pattern to the second one. It was 1, now there are 5. So if I subtract 5 minus 1, what am I going to have? There's a difference of 4. 9 minus 5, there's also a difference of 4. So it means I was simply adding from one to another, I was simply adding a 4. 1 plus 4, that's a 5. This 5 that we have, we add a 4, we get a 9. So from these 9 that we had, if we add a 4, 9 plus, we are going to have 9 plus 4, 13. We are going to have 13 squares made up. So that was not the part of the question. This is just, we are studying. Remember, they said study, so you're supposed to analyze up to that extent. Anyways, 6.11, write down an algebraic rule that describes the number pattern. This number pattern, 1, 5, 9. As we saw that there's a difference of 4. Remember, I told you guys that whenever they want the rule, they are talking about Tn, the statement that connects the number of terms, which is Tn. And I said Tn is equal to the difference that you are given. If it is a linear pattern, there's a common difference. So you take the difference here times n plus a certain number that you're going to need here. So this one, it represents, this box here is for the difference. So what is our difference? Our difference is 4. So Tn is equal to 4n plus. There's a number that you need here. So how do I find this? What is going to represent this box here? Okay, this is what you can do. You just take what you're given from your question. Your first term is 1. Your first term is equal to 1. Your first term is equal to 1. So it means when I have n, this one, it represents n. Remember, Tn, n is equal to 1 and T1 is 1. So it means 1, this one for T1, it is equal to 1. When n is 1, so it's 4 times 1 like this, plus what we do not know here. So 4 times 1 is 4, then we transpose it. This side is going to be 1 minus 4, which is minus 3. So minus 3 is equal to the number that we do not know that side. So therefore, our Tn, this one, can be written as 4n. Remember here, there's already what? 4n. Then this block here, we must have what? Minus 3. So it's plus minus 3. Plus minus 3, it's what? Minus 3. That is your Tn. This is the rule that connects the input to the output. Okay? Just like that. Just like that. Then on 6.12, using your answer from 6.11 from that rule that we had. Remember, our rule is Tn is equal to 4n minus 3. So using that rule that we had, determine the number of squares that will make up pattern number 6. So as we see from our pattern numbers, they're just growing. These pattern numbers are just moving, like pattern number 1, pattern number 2, pattern number 3, like first term, second. So your pattern number 1 is your first term. Pattern number 2 is your second term. Your pattern number 3 is your third term. So what does it mean about our pattern number 6? Our pattern number 6 is the nth value. Our n is equal to 6. So the question is simply calculate T6. When n is 6, that's T6. So that is going to be 4n. Remember, 4n means what? 4n, 4 times 4n, 4 times. So that's 4 times 6 minus 3. That's like just like that. That's 24 minus 3, 24 minus 3, which is 21. So there will be 21 squares at the end. We are going to have 21 squares at the end, which are according to what you're given there. Then which pattern number will be made up of 1,000 to 1,025 squares. So now it's a continuation again from the same Tn that we are given, which is 4n minus 3. So this time you're given, remember here, guys, what were you calculating? The number of squares, which is Tn, T6. So they gave us this time the number of squares. So it means they gave us Tn. Tn is equal to 1,025. 1,025. You are given Tn, the number of squares. So the question is, what is n? Which pattern? The pattern number, it's n. That's your pattern number. What is n? So it's an equation. This Tn, which is an expression, and this Tn, which is a numerical value, they are equal. So you can form an equation when it is like that. 4n minus 3 is equal to 1,025. Remember your linear equations. How do you solve these equations? I have to remove the minus 3. It's a constant. There is no n there. It's a constant. This one, it's a variable. So I have to remove this minus 3. But how do I remove minus 3 from this side of the equation? I take it to the other side of the equation. It must jump the equal sign. The moment it jumps the equal sign, or the moment it crosses the equal sign, it must change its sign. The sign is a negative, so it is going to be a plus 3 on this side. So you add a plus 3. So you are adding a plus 3 here. You are adding a plus 3 here. That is the concept, to remove this minus 3. You add a plus 3, you add a plus 3. So that is going to be 1,025 plus 3, which is 1,028. This is 4n, which is equal to this. 4 times. When you are multiplying, the number does not cross like what minus 3 did. When you multiply, the opposite of multiply is divide. You divide by that. You divide to remove a product, a times. You divide. So 1024 divided by 4, this was going to be 257 on your calculator. So that's n is equal to 257. That is, we are talking about the 257th number pattern that we have on our number pattern. So that was what we had, 3 marks, which is a total of 8 on this part of our question. So be careful how these questions might be given. This is how your questions might be given. You just have to be careful, attempt them properly. All right. Question number 7, we are given, this is an input and output. All right. Y is equal to, so this X is for the input. Remember, X is input, then Y is output. Complete the table, all right? Complete the table by writing down the value of A and B. So this is 1, 2, 3, and so on. So A is the output when our input is 1. So A is the output when the input is 1. So you just substitute here. Y is equal to, in place of this X, you substitute. So it's minus 1 squared plus 2. Just like that. You are given the input is minus 1. So just substitute there. So that's minus. Open a bracket, put the minus, put the 1 inside of the bracket like this. You square it, then plus a 2. So the answer is going to be a 1. So A is equal to 1. Okay. We move on to another one to find B. B is the input when the output is minus 34. When the output, which is Y, so minus 34 is equal to this minus X squared plus 2. All right, I want to solve for X. I can take this to the other side. It becomes a positive. X squared is equal to, take minus 34 this side. So it is going to add on this side. So it's 2 plus 34, which is 36. So the question is, how do we find this X? Because there we are given X squared, as we need X. So to remove a square, you introduce the square root to both sides. So X is equal to the square root of 36, which is plus or minus 6. But as you can see, these numbers are increasing. 1, 2, 3. They are positive. So X must be a 6. And X represents what? The input, which is our B. So our B there was going to be a 6. Question number 8, algebraic expressions, 8.1. Answer the questions related to the following expression. This expression, 2a minus 4a squared minus 8a. 8.11, are the terms 2a minus 8a like or unlike terms? Provide a reason for your answer. So 2a and minus 8a, these are like terms. We have got a, we've got a. They are of the same exponent also. So these are like terms. All right. So these are like terms. So the reason that we are having is that we have got the same variable, same variables, and the exponent is the same. And the exponent is also the same. And exponent and the exponent and the exponents are the same also. Are the same, okay? So if you check the exponent, there is 1, the exponent is 1 and the same. Like the variable, we are talking about a, having a. If I am given X and Y, before I talk about exponents, these two variables are different. They are unlike terms. So the first thing is that we must have the same variable, same exponent. These are like terms. Same variable, same exponent. Okay. So that is what we needed. Write down the equivalent of this expression. So since these are like terms, we can collect our like terms, the a and the minus 8a. So it's 2a minus 8a minus 4a squared. So 2 minus 8, we can simplify that. 2 minus 8, that's minus 6a minus 4a squared. We cannot simplify this a squared to a to the exponent of 1. These are unlike terms. So this is your final answer. You are done. Just like that. Then 8.13, determine the value of the expression if a is equal to minus 1. So you can substitute back here, which is fine. It's 2 into minus 1 minus 4 into minus 1 squared minus 8 into minus 1. You can even just use your calculator there to simplify. That will be 2 times minus 1, which is minus 2, minus 4 times minus 1 squared, that's minus 4 plus 8, and that is going to give us a 2. Or you can just use this part here, because this one is the one that you simplified before, and this is what you got. So you can simplify from there, from here. Minus 6a minus 4, already this is what we have. So you can just substitute there. Okay, still you must have the same answer. That is the one that you got. Minus 6 and minus 1, that's a positive 6. Minus 1 squared, that is a positive 1. So it's going to be minus 4. 6 minus 4, that is a 2. Exactly the same answer that we got. So this is the working that you could have taken, either one of these. I don't know which one were you going to prefer to work from the original part or not. So you put in your information. That is 3 marks for that. All right, 8.2, simplify the following expression fully. Minus 8 minus x squared, minus when raised to a negative, and negative when raised to an even exponent. Remember, I said it changes to be positive. So minus squared, that's positive. So it's going to be positive x squared plus b minus x squared. What is the square root of b squared? The square root of b squared is a b. Remember, the square root, there's a 2 there. So the square root of b squared, it means there's a 2 like this, square root of b squared. So to remove the 2 under the square root, is just divide 2 over 2. That is going to be b to the exponent of 1. So just a b. Collecting like terms, we can see that there is x squared. There's also x squared there. There's a b and a minus b. This is same as we've got 1x squared minus x squared. That's a 0. 1b minus 1b minus 1 minus 1, that's a 0 again. So this whole was going to give us a 0. Just like that. Just like that. So meaning to say at the end, that's a 0. 8.22, simplify this again. There's a bracket that we are given on this part. So you just have to expand your brackets. Minus 6 is expanding the bracket. So it's minus 6 times 3a, that is minus 18a. Minus 6 expands everything. Minus times minus, that's a plus. So 6 times 2, that is going to be 12b. This part is not inside a bracket. Just rewrite as it is, plus 6a minus b. You are back to that part of the like terms, so you can collect your like terms, the part with a on its own. So this is the part of a on its own, then the part of b on its own. So make sure that you collect your like terms, the part of a on its own, then also the part of b on its own. That is the idea there. All right. So guys, this software of mine just ended just like that. Very, very, very sorry guys for this one. You see these softwares, guys, what they can tend out to. Okay, let's hope we'll be able to finish. Very sorry for this. You see, guys, these softwares, they can tend to just misbehave. All right, anyways, we're almost there. That's collect your like terms. We're gonna take the part of A, the part of A, this one. That's minus 18a plus 6a. Then the part of B, plus 12b minus b like this, okay? Then if you subtract minus 18 plus 6, guys, I can't even show the calculator now because see what happened. It can affect everything. You're going to get minus 12a. 12 minus b, this is the same as there's a 1 here. There's a 1 which is invisible. So it's 12 minus 1, which is 11. So that will be 11b. So it's minus 12a plus 11b at the end, which is a total of 3 marks and a total of 12 marks from the whole of our question 8. So that is it on this question paper. That is it. Yes, that is it on this question paper. This is what we had on this full paper. So make sure that you do revise as many questions as you can to master for these typical control tests that you are going to have at the end.